Sorry for the delay. I had a bunch of stuff happen all at once this morning and had a bunch of things to deal with. So, there we go. All right. So, I didn't get a chance to write this on the board, but I'm going to try and wrap up chapter 4 today. But just in case I still have some lingering things, I will have the notes, the guided notes due next Monday on Canvas or next Tuesday in class. Either one is fine. And somebody else in there. Let's see. We've already done the videos. Oh, I will be posting homework 4B as well. So guided notes and homework 4B due Monday night online. And if you want to do your guided notes on paper and hand it in class, that is fine as well. We are going to be looking at the second couple of pages. So we did all of the stuff on sugar in the guided notes, but now we're going to be looking at the stuff on acids and bases. So the reason, of course, is because acids are how we taste sour things. Many bases also taste bitter. Not all bitter things are bases, but many bases taste bitter. So we kind of got those things combined to tell us about flavor. And then we got a couple of things we're going to test out here. I had tried to use these powdered egg whites to make some egg whites that we could work with to test today, because, eggs are not cheap anymore. And they just did not work out. They were a complete mess. And so I had to bring in some eggs from home. So we'll have to kind of stretch those out to make those work. But we will get all of this together in just a minute. All right. So I'm going to pull up our PowerPoint. Are there any questions about logistics, about when stuff from chapter 4 is due? Anything? I think there are still 2 or 3 of you who need to finish taking the exam from Thursday. You missed the exam on Thursday. You need to get that made up in the next 2 days. So make sure you check with me for when that can be done, because I'd hate to give you a 0 on that. Still in the corner if you haven't quite gotten to it yet. So we are talking about acids in particular. We'll talk a little bit about bases because they're kind of the counterpart to acids, but mostly we'll talk about acids. So we've all heard the term acid before in a variety of scenarios. People talk about having acid reflux. You've heard of acid rain. Lactic acid, that's something that can build up in your muscles when you exercise a lot, and that can lead to cramps. Carbonic acid is something that is in anything that is carbonated that you have had to drink. So whether that is a soda or champagne or just seltzer water or, a variety of things like that, those are all carbonic acid. You've probably heard of battery acid. You may have heard of citric acid. So these are terms that we've heard before. The terminology for acid has been around a lot longer than our understanding of atoms. And so where we get our idea for acids really has more to do with things we observed about what they did rather than what they were. And we've just sort of narrowed down, well, what are the kinds of things that lead to these observations? So early chemists recognized that if we had something that is aqueous, remember aqueous means it's in water, that some of these liquids had these properties. They would conduct electricity. They were corrosive. So corrosive means that it can damage any kind of a material. We sometimes think of it as making metals rust, but it could be damaging to wood or to plastic. It's just somehow damaging to materials. Of course, plastics wouldn't have existed early on. They tasted sour. And so they kind of grouped these things that did all this stuff together and called them acids. And I want to remind you at this point that sometimes we think of acids as being bad. Like if we think of acid reflux or acid rain, we think, oh, that's not a good thing. But chemicals aren't good or bad. They don't have a moral code. They can have harmful properties. They can have helpful properties. Sometimes the same chemical can be both helpful and harmful, sometimes at the same time. The acid in your stomach is supposed to be there. It does a lot of good for you digesting food, but it can also be damaging when it splashes up into your esophagus. That's what acid reflux is. So just kind of remember that when we talk about these chemicals, try not to think of acids as the bad thing. And the reason that that's important is because we said bases are the counterparts to acids. We don't want to be thinking, oh, if acids are bad, bases are good. That's not really how that works. All right, so chemically, what are they? Well, first let's think about water. If we picture a water molecule, often chemists will use the color red to represent oxygen, but water is H2O, so we have 2 hydrogens and 1 oxygen here. And most of those molecules stay together as a complete molecule. But within any glass of water, any drop of water, 1 in every, let me think what it would be, 10 million, 1 in every 10 million molecules will split apart, and it will form the negative OH and a positive H plus. So this negative OH here is associated with bases, and the positive H plus is associated with acids. And I just remembered that since we're going through stuff on the guided notes, Isaac, did you ever print this out? Okay. Did anybody else not get the guided notes for chapter 4? Okay. All right. So if I have a situation where some chemical has been added and they aren't equal, then I either have an acid or a base. So when water splits apart, I have equal amounts of both of these, and it's neutral. They cancel each other out. But if I have hydrochloric acid, then I have a lot more of the H pluses and a lot fewer of the OHs. Okay, so whatever I have excess of is going to tell me whether I have an acid or a base. So if I have extra H plus, that gives me an acid. If I have extra OH, then I have a base. If I mix the two together, then I get water. And then the H plus and the OH probably didn't come by themselves because they're ions. They had to be attached to something. So if I had H attached to a Cl, HCl is hydrochloric acid, and OH attached to sodium, Na, so that would be lye, what is used to clean out drains. If I mix those two things together, then I'm going to get water, but I'm also going to get NaCl. What's NaCl? That's salt, right? So whatever those other ions are that put together that ionic compound is generically called a salt, but sometimes we legitimately get table salt, okay? So mixing the two together is neutralization. Neutralization creates water and salt. All right, so there are 2 ways that we can recognize acids. If you ever see a compound where the H is written first, that's usually an acid. Now we do write H2O. Water can act as an acid because it can neutralize bases. But in general, if I think of something that's going to add more hydrogen other than water, usually if the H is out front, then that tells us it's an acid. So HCl, this is what's in your stomach, hydrochloric acid. This is nitric acid. And then that one is sulfuric acid. Sulfuric acid is what is in car batteries. So when you say battery acid, we're talking about H2SO4. That is the most produced chemical in the United States, is sulfuric acid. But most of the acids that we deal with, particularly with foods, are organic acids or carboxylic acid. So we've looked at this before. This is when we have this group here where it has a carbon attached to two oxygens, and then there's a hydrogen off of one of the oxygens. So this group here is called a carboxylic acid. And on this molecule, we call this acetic acid. So acetic acid is what's in vinegar. This molecule has three of them, and that is citric acid. So citric acid, of course, is in citric fruits like lemons and oranges and limes, but it is also the acid that is on sour candies. So if you like, Warheads or Sour Patch Kids or whatever, those have this acid sprinkled on top of it. Okay, so those are edible acids. Carboxylic acids, when we write out the formula, usually have this as part of the formula, COOH. So this is showing the carbon is attached to two oxygens. And here we have acetic acid is here, and this is citric acid with the three showing the three COOHs. Okay. Folic acid is like that. So if you've heard of folic acid as being one of the vitamins that you need, vitamin C is also an acid. It's ascorbic acid. So we'll talk about more of these acids as we go along. All right. So we talk about some of the properties of acids. Which one is not one of those properties that was first recognized? So most people said D, which is correct. That is cause cooling sensation. So something like mint could do that. Acids may or may not do that. It kind of depends on what else is on the molecule. Okay, so the way we measure acids is what's called the pH scale. You've probably heard of this. The pH scale goes from 0 to 14. Now, actually, it can go negative or be a little bit higher than that, but basically it goes from 0 to 14. So 7 being right in the middle is neutral, and that's what we consider water to be. Now, in actuality, water that would be in a lake or water that's coming out of the faucet is going to have dissolved gases and minerals in it, and those are going to slightly change the pH. So everywhere in the country, it'll be a little bit different, but in most places, it's somewhere between 5.5 and 6. So it's slightly acidic. All right, so here is neutral. Your blood is a little bit higher than neutral. It's got, because of the carbon dioxide in the air that dissolves into your blood, that becomes part of regulating your blood's pH. And so we get the base carbonate in your blood, and that helps to bring that pH up a little bit. Milk is a little bit lower. Coffee, if it's black, is going to be a pH of 6. And then sodas might be anywhere from 2.5 to 3.5. So sodas have two different acids in them. So if you have a clear soda like Sprite or 7-Up, that's going to have, like I said, carbonic acid. That's what gives it its bubbles. But if you have a cola like Pepsi or Coke or something like that, they add phosphoric acid to drop the pH even lower, gives it a little bit more of a sour flavor to it. And then lemon juice and vinegar are probably the lowest pH that you would actually consume. That would be around 2. And if you've ever tried to have apple cider vinegar straight, some people will say, oh, take apple cider vinegar, it's good for your health. If you've ever tried to do that, that can be really hard to do. So you wouldn't try and have something at a pH of 2 straight very often. You would only have that in very small amounts. So this is about as low as we can go. Battery acid's going to be down here around 0. Stomach acid is probably going to be between a 1 and a 2. Okay. So very low pH. That's where our acids are. High pHs are where bases are. And if we look up here, there aren't a lot of foods. So we have our blood, we have seawater, baking soda. This is the one thing as a base that we do consume is baking soda. That's about a 9.5. And then we have ammonia, bleaches, liquid drain cleaner. So a lot of cleaners are bases. Bases are really good at breaking down fats. And so that's why we use them to clean things, because a lot of the dirt that we are trying to get rid of might have oils or fats in them, and the bases can break those down. But foods in general, especially fruits and vegetables, those kinds of things tend to be lower in pH. All right, so you have a chart that lists characteristics of acids and bases. The ion associated with them, the negative, the OH negative is called hydroxide. H plus we said was the other side of the water molecule. But if we think about what hydrogen is one proton and one electron. And if we take an electron away, we're left with just a proton. Well, protons don't just hang out by themselves. So it kind of gloms onto another water molecule and we get this H3O plus. So the acid is associated with H3O plus and we call that hydronium. Okay. So you should anticipate, we'll probably do a quiz sometime next week. You should anticipate on the quiz being asked either or both of those. What's the formula for hydronium, or which ion is associated with bases, something like that. Acids are sour, so remember that hydrogen ion can go through the channel in our taste buds, so it actually gets into the cell, unlike some of the other flavors which just kind of dock on the receptors. But the ions, sodium and hydrogen, can get into the cell, and as that charge gets in there, that's helping to move around calcium and create an action potential, which sends a message to the brain, and so on and so forth. Bases tend to be bitter. There are a lot of bases that have nitrogens on them, and the nitrogen can be part of an alkaloid, and the alkaloids tend to be bitter. So we'll talk a little bit more about that later on. And then we said low pH, high pH, acids being low, bases being high. Both of these are corrosive if they're strong. So we said water is a little bit acidic. We don't really think of water as being corrosive. We don't think of milk as being corrosive. But once we get down to the 4 or the 3 or the 2, that's where if I'm leaving that acid sitting on metal, it's going to start eating through that metal and corroding it away. And if it's down at the pH of 1 or 0, then even other materials could be corroded. Well, the same thing is true of bases. Bases can also be corrosive. There is another word that we use that is similar to corrosive, caustic, C-A-U-S-T-I-C, caustic. And that means that it's damaging to your skin. So both of these are also caustic. If you were to have lye, which I said was the drain cleaner, if you were to get that drain cleaner on your hand and not wash your hand right away, that could give you a chemical burn. It would appear red if you washed it pretty quickly, or if you just left it on there, you didn't realize it was there. Hours later, it would start to feel very painful, and you might get a welt, or you might have your skin damaged permanently and have a scar. Same thing with a strong acid. If you got battery acid on, you could get a chemical burn, that kind of thing. So this is where I say, don't think of one as being good and one as being bad. Both of them can be harmful in the extreme. They neutralize each other. So if I have something that is acidic, I can neutralize it with a base. Well, we said bases tend to taste bitter, and most people don't really like bitter flavors. Now, it kind of depends. As we mature, our palates like more complex foods, and sometimes bitter can be part of something that makes something taste more complex. But if you don't like the bitter flavor, then adding an acid to it can help take that bitterness away because it neutralizes it. So if we think about having a salad which maybe has some nuts that have some of these alkaloids on them, a little bitterness to them, then putting a vinegar on the salad is going to neutralize that, and so it's not going to be as bitter anymore. Okay, so they can neutralize each other. We can also use this kind of around the house with non-food items. If we know something is a base and we want to get rid of it, we can use an acid. If we know something is an acid and we want to get rid of it, we can use a base. So for example, if you have old pipes that have rust in them, you might end up in your sink or your bathtub or your toilet, orange stains. Well, that orange stain is a base. So using a little vinegar to clean it up will work. And then we said that bases will take away or will dissolve fat, so we can kind of use that in reverse as well. So the acids are going to dissolve rust, which is a base. They're also going to dissolve lime. Lime is the white material that gets on things. It's calcium oxide. So instead of iron getting there, calcium getting there. We use our coffee pot at home just to heat up water. We like tea, we like hot chocolate, whatever. So we'll heat up water in there. And because we live in Georgetown and Georgetown has hard water, after a few uses, it gets white material stuck to it. That's the lime. And so every once in a while, I'll take a little vinegar and rinse it out and it's clean again because the lime is a base and that base gets dissolved by the acid. All right, so then you have the word on your handout that is an anhydride. So an anhydride is when you take water away from something. So if I take this chemical here, this is the acid carbonic acid, and I take away H2 and one of the O's, then I'm going to be left with CO2. So CO2 is the anhydride of the acid. So as a general, non-metal oxides, if I have one of my non-metals, carbon, nitrogen, sulfur, phosphorus, any one of those mixed with oxygen, that is what we call an acid anhydride, okay? Similarly, if I have a metal, and that's the whole rest of the periodic table, attached to an oxygen, that is a base anhydride. So we said calcium oxide was lime. The reason why that reacts with an acid is because it is a base anhydride. So this is a base, add it to the water, and you get that OH ion. Okay, so a metal plus oxygen is a base anhydride. It is a base, but it's a specific kind of a base called an anhydride. All right, so that should fill out that table on your guided notes. Is there anything else on that table that I missed? Okay, I hit most of that. All right, so we talked a little bit about pH. If a solution with has a pH of 3, is it acidic, basic, or neutral? Most of you said acidic, and that is correct. So low pH, and that's a little bit counterintuitive. So remind yourself in your brain, if you got that wrong, remind yourself in your brain. It seems like more acidic would be a higher number, but more acidic is a lower number. So it's a little bit counterintuitive. All right, next question. What does a basic solution taste like? So we said cleaners like soap. If you get soap in your mouth, what does that taste? That is correct. Bitter. So bitter is the only flavor that we have that starts with a B. So bitter and base go together. So that can be a way you can remember that. Sour is associated with acids. Okay, so let's get back to foods. Almost all foods are at least slightly acidic. Fruits can be very acidic because there are several acids that are associated with them. So like cranberries are with lemons. They have really low pH. Apples, you don't think of apples as being particularly sour unless you're eating like a Granny Smith. And they tend to be about a 3.5. And they do have a range. It kind of depends. So green apples are probably a little more sour and red apples are a little more on the sweet side. And then, as I said, milk is slightly acidic, not acidic enough that you would notice. All right, so what happens when we mix that sourness with other flavors? So a lot of flavors that we think of as being sour are also because we're mixing with other things. So something that is sweet and sour both is kind of a tart thing. Something that is salty and sour, like salt and vinegar potato chips, that's kind of a tangy flavor. And then remember, if we mix the bitter and the sour, we're going to get a neutralization. Often it does taste salty if that neutralization involves sodium in there as well. All right. We had a list of characteristics of acids, which is a characteristic reaction of acids when interacting with other substances. What do acids do? Dissolve rust and lime, neutralize fats, increase pH levels, or form salts by combining with sugar. All right, very good. We're dissolving rust and the lime. So bases will break down the fats. Bases will also increase the pH. Okay, so some common acids, things you should be familiar with. Acetic acid is a vinegar. One of these is not on your list. I forget which one is not on your list, but acetic acid is vinegar. And I've talked about that before. I'll talk about it again. That's a real important one to know. And then we mentioned that citric acid is in lemons and limes. Also tangerines, oranges, that kind of thing. Those foods also have vitamin C. So vitamin C is ascorbic acid. And then malic acid gets its name from apples because mal refers to apples. My kids used to watch, what was it, Descendants or something like that on the Disney Channel. And like one of the daughters of Snow White was Mal because Mal means apple. Something like that. I didn't watch the show. All right. That's found in apples. It's also found in bananas. And then there's tartaric acid, which is found in grapes. And of course, if it's in grapes, it's going to be found in wine as well. And it's found in tea. So we talked about astringency. Astringency is that kind of rough feeling your tongue gets. That this is one of the places that that can come from. The tartaric acid has that way of kind of changing the texture of your tongue. So even though you're drinking a liquid, it kind of tastes dry. Lactic acid, found in your muscles, but also found in milk. So lactic referring to milk. The lactic acid in your muscles doesn't come from milk. It just happens to be made into the same molecule through the chemical reactions that your muscles are doing as they're exercising. And then carbonic acid, that would be in soda or in champagnes. So that's our bubbly stuff. And then phosphoric acid is in sodas. So you definitely should know acetic, citric, and carbonic. That's why those are bold. And then any other that happens to be on your sheet there as listed is one that I might ask about on a test or a quiz. So that's why it should be in your notes so that you can refer back to. That phosphoric acid would be in soda.